Hello, everyone, and welcome once again to iTeach Cybersecurity Academy, or simply iTCA, the online academy built on one clear mission: to make cybersecurity simple, useful, and practical for everyone. At iTCA, we don't assume you already speak tech. We start from the basics, explain concepts clearly, and connect everything to real-world cybersecurity, so nothing feels abstract or overwhelming. You're enrolled in the Introduction to Data Communication Beginners course, and this is Module 1, Introduction to Data Communication and Communication Models. This module is extremely important because it lays the foundation for networking, cybersecurity, digital forensics, and threat intelligence. If you truly understand this module, everything that comes later will make far more sense. Let's start with a hard truth that many beginners don't hear early enough. Every cyber attack, every data breach, every online scam depends on data communication. Attackers don't steal systems, they steal data, either while it is being stored or while it is moving. If you don't understand how data moves, you cannot fully understand how it is attacked or how it is defended. That's exactly the problem this lesson is designed to solve. By the end of this module, you won't just memorize definitions. You'll understand how data communication works from the ground up, so future cybersecurity topics don't feel confusing or disconnected. This lesson is designed for beginners, students, career switchers, and anyone who wants a solid foundation in cybersecurity done the right way. So, let's begin with the most important question. What is data communication? Data communication is simply the process of sending data from one device to another through a communication medium. This happens every time you send a message, browse a website, stream a video, or log into an online system. From a cybersecurity perspective, this moment, when data is moving, is one of the most dangerous moments. Data in transit can be intercepted, modified, redirected, or stolen if it is not properly protected. A good way to think about data communication is like sending a sealed envelope. The sender matters, the receiver matters, the contents matter, but the journey matters just as much. Cybersecurity is largely about protecting that journey. Every data communication system is built from 5 essential components, and understanding them helps us see exactly where security controls are needed. First, we have the sender, which is the device that creates and sends the data. If attackers compromise the sender, they can steal information before it even leaves the system. Next is the receiver, the device meant to get the data. Attackers often impersonate receivers to trick users into sending sensitive information. This is how many phishing attacks work. The message is the data itself: passwords, files, videos, financial transactions. Protecting the message is the core goal of cybersecurity. Then we have the medium, which is the path the data travels through. This could be a cable, Wi-Fi, or the internet. Attackers often monitor or tap into this path to intercept data. Finally, there is the protocol, which defines the rules of communication. Weak or insecure protocols expose data to interception and manipulation. Together, these 5 components form the backbone of secure communication. Now, let's talk about the types of data being communicated. Data can be either analog or digital. Analog data is continuous, such as human voice or radio waves. Digital data is discrete and represented using ones and zeros. Cybersecurity systems primarily focus on digital data, but it's important to understand that analog data is often converted into digital form before transmission. If this conversion process is insecure, attackers can exploit it. This is why data communication is so important in modern networks. Banking systems, healthcare platforms, military communications, cloud services, and cybersecurity monitoring all depend on reliable and secure data communication. Without understanding how data communication works, cybersecurity becomes guesswork instead of strategy. As data moves from one device to another, it doesn't move randomly. It flows through layers, and each layer has a specific responsibility. This layered thinking is critical because engineers design networks this way and attackers target networks this way. Understanding layers helps defenders know where and how to protect systems. One of the most important layered models is the OSI model, which divides communication into 7 layers, starting from physical transmission and ending with user interaction. The physical layer deals with cables and signals and can be attacked through physical tapping. The data lake layer manages communication between devices and is vulnerable to spoofing attacks. The network layer handles routing and IP addresses and is targeted by IP-based attacks. The transport layer ensures reliable delivery and is often targeted by session and flooding attacks. Finally, the session, presentation, and application layers handle communication sessions, encryption, and user interaction, where phishing, malware, and application-level attacks often occur. In real-world networking, we commonly use the TCP/IP model, which simplifies the OSI model into fewer, more practical layers. The network access layer handles physical transmission. The internet layer handles routing and IP addressing. The transport layer manages reliable delivery. And the application layer supports user-facing services like web browsing and email. Most cybersecurity tools analyze and protect traffic at these layers, which is why understanding TCP/IP is essential. The relationship between OSI and TCP/IP is simple but powerful. OSI helps us learn and analyze, while TCP/IP helps us build and secure real systems. Together, they give cybersecurity professionals a complete picture of how data flows and where it can be attacked or defended. Think about what happens when you visit a secure website. Physical cables carry signals, networks route packets, transport protocols ensure delivery, and encryption protects your data at higher layers. Every layer is both a potential risk and a potential defense point. This is why cybersecurity always starts with understanding data communication. Let's quickly recap what you've learned in this module. You now understand what data communication is, the components that make it work, the difference between analog and digital data, how data flows through layers, and how the OSI and TCP/IP models explain real-world communication. Most importantly, you now see that cybersecurity begins with understanding how data moves. If you're serious about building a strong foundation in cybersecurity, don't stop here. Continue to Module 2, where we explore network architectures, network types, and transmission media, and you'll see how network design directly affects security, attacks, and defense strategies. If you found this lesson helpful, like, share, and subscribe. Stay with us, and let's keep building your cybersecurity knowledge the right way, step by step.